See, we were trying to focus on how the routing happens in SD-WAN. We learned a lot of things about the components of SD-WAN and why SD-WAN, all the stuff in our past. And what we learned is there is an orchestration plane called vBond, and then there is a management plane called vManage. There is a control plane called vSmart, and then there is a data plane called VH. And we learned the roles of these things earlier in our past. And when we talk about routing in SD-WAN, we may have a static route. We may have a protocol OSPF redistributed or BGP redistributed. What these things are, where we redistribute, where do we use the static route in SD-WAN, OSPF in SD-WAN, BGP? That's what we are going to, we are trying to understand from the previous class and this class. Right. So to understand this, we were focusing on various protocols. EAGRP can be an option if we have Cisco's C edge device. Otherwise, only BGP, OSPF, and static route is the option. Then we were talking about the different network types and their functions. There's an underlay network and there's an overlay network. Underlay network is the WAN connection that is between the sites, between the offices. We have many offices, many branch offices. Between the branch office to communicate, we have got some sort of WAN connection. Maybe you have one MPLS connection. Maybe you have one MPLS connection with high priority for means QoS with QoS. MPLS with QoS is one WAN connection you got. Another may be a simple MPLS connection. Another may be an IPsec with MPLS. Another may be simply IP. So you may have multiple WAN connections as an underlay. Did you understand what I said so far? Okay, so we have underlay, and we also have overlay. Overlay is the SD-WAN tunnel. Overlay is the SD-WAN virtual network between the sites, between the branch office and the head office. And this overlay is possible because of the protocol OMP. OMP stands for Overlay Management Protocol. Without underlay, we cannot have overlay, correct? Definitely not possible. So underlay support is very important, meaning you need to have a very good WAN connection between the branch office. You may have multiple connections of different types, MPLS, with QoS, without QoS, and IP, tunnel with IPsec, tunnel with GRE. You know GRE? You know IPsec? So you may have a different type of connection with your ISP. You might have purchased IPsec tunnel as well as GRE tunnel. For some traffic, you want to go via GRE. For some traffic, you go via IPsec. For some traffic, simple MPLS. For some traffic, MPLS with a QoS. So you got MPLS, you got internet, you got many more as an underlay. As an overlay, the overlay network will never worry about what underlay you have. For overlay, please complete it. You are trying to say something. Finish it. What you're saying? It can translate the. Hmm. Sorry for interrupting. Hmm. Very good. See, it will use underlay to transmit data between the branch offices, between the branch office and the head office. But the overlay will not focus on whether I am going through MPLS link or a GRE tunnel or IPsec tunnel. It will only focus on OMP provided routes. It will only focus on OMP provided next hop address. It will only focus on T-log. So we are going to focus more on transport locator and OMP to understand this overlay better. We need to understand this overlay better. Have you done MPLS layer 3 VPN? It's okay. You have done. You know very well about VRF. You know how the MPLS, MPBGP tunnel is established. Those idea a little bit, if you have, you will understand these things very easily. See, this SD-WAN overlay is a mixture of layer 3 VPN, MPLS layer 3 VPN, segment routing, frame relay. They have copied the ideas from all this and they have put it here. Lisp. In Lisp also we use the TLOG, transport locator. Location identifier. There we called as location identifier. Here we called as transport locator. Anyway, our focus is today more on this OMP, this TLOG. Overlay network or abstract away from TLOG where the links are distributed into OMP as TLOG abstraction. As I said earlier, that's what I'm going to repeat now in detail. See, to be very clear, all the edge devices, just imagine one edge device in Mumbai. From Mumbai, the LAN networks, you can also compare this to MPLS layer 3 VPN. A customer is advertising his LAN network using BGP or OSPF. He advertises the route to the provider edge router, correct? Same like that. The edge devices are going to use OMP. Advertise the LAN networks to whom? Be smart. Likewise, every edge will from Mumbai you advertised. From Bangalore, I advertised. From Pune, my friend advertised. From Delhi, my another friend advertised. We all have advertised to vSmart. Now vSmart knows about everyone. vSmart knows the location of every LAN network. vSmart knows network 20 is in Bangalore. Network 10 is in Mumbai. Network 30 is in Pune. Network 40 is in Delhi. vSmart knows very clearly. But these 10, 20, 30, 40 networks are what? LAN networks, not public networks. To reach this LAN network, I need to know the public IP address. If I want to come to Mumbai, 10 network, from Bangalore, 20 network, I need to know the location of Mumbai network, the public IP address. Now, in Mumbai as well as in Bangalore, we have two connections. One is MPLS connection, another one is internet connection. Now, I need to know which service I'm going to use. Depending on the service, the IP address in Mumbai also will vary. Yes or no? If I am using MPLS service to reach the 10 network, IP address will be different from the internet service that I use to reach the 10 network. Yes, no? That is what transport locator provides. Transport locator provides this knowledge to the Bangalore router which next stop to use in order to reach that LAN network. But these advertisements comes through whom? OMP. OMP is the only protocol that works in between the vSmart and VH. OMP will not talk in between VHs. Your Mumbai router will not come and give it to me. My Bangalore router will not come and give it to you. We give it to vSmart using OMP and using OMP, and a OMP route is created. We also call it as V route. A V route, a virtual route is created with what? Transport locator for each network. With transport locator for each LAN network from various remote sites. You understood? T-log is the identification for me from Bangalore to reach Mumbai's edge device. We are going to go in deep. No, don't worry about diagram. I'm going to go in depth. I'm just trying to give you an overall now. So far, we have clearly understood one thing, that there is a protocol called overlay management protocol. This runs only in between VH and vSmart. We have learned up to here now. And we also learned that there is something called TLOC, transport locator. Only with the help of transport locator, the virtual overlay connections will know to whom to deliver. Transport locator is like a next hop address to reach some network. How do I know, sitting in Bangalore, how do I know the next hop address to reach that 10 network? How do I know the public IP address of Mumbai edge router? I learned through OMP as TLOC. Not only next up, there are many more things we are going to discuss now. As of color, correct. Many things. We are going to go in depth into it now. So, overlay network does not care about underlay, not in any specific way. Those links are abstract into TLOG, where the links are distributed into OMP as TLOG abstraction, as a TLOG update. So, how do overlay knows about the underlay? As a TLOG abstraction, as a TLOG's update. I give you one small example, like stop. There are many more things. So overlay net. Okay, one more thing. Before I get in deep into those things, I also want to remind you a few things. Overlay network only knows the inter-site link using OMP. Overlay will not know anything about the physical underlay. They know only about the inter-site link using OMP over the transport network of VPN 0. VPN 0, VPN 0 is what used by the OMP in order to provide the topology information, provide the inter-site link information over the transport network. What is transport network? The underlay network, the WAN, the service provider MPLS, internet, and so on. So overlay network only knows there are transport connections, means MPLS network, internet network between the sites. Using the OMP, they knows this locations via VPN 0. VPN 0 is the one which is reserved for this purpose, for the discovery of the underlay and means the transport which will be used by the overlay. So you should not have any confusion here. Let me try and explain it. Yeah. We have a transport, which is an underlay. Example MPLS, internet. So, and then we have an overlay. This is where we get a lot of services. What services? MPLS service, MPLS with QoS, firewall service, IPsec, GRE channel, internet. How do you obtain those services? Using the OMP routes. It's not underlay routes. This is not an underlay route. Underlay may be MPLS, underlay may be internet. Using the underlay, overlay has created a separate control plane called OMP routes. You have OMP routes. Depending on the user's need, users' routes are advertised to the vSmart, and from there on it becomes OMP routes. If one user wants to go from one branch office to another branch office, he uses that OMP route. It's a route that is providing the path information not via the underlay, but via the overlay tunnels. See, overlay tunnel is also like a mesh topology only. In there also you need a path information, route information. If I want to go to Mumbai, this is the next stop address. If I want to go to Delhi over the tunnel, this is the next stop address. No, the discovery of routes, yeah, Yep, you can say that. VPN 0 actually the route information is provided. You're right. What you understood is correct. VPN 0 is the one which is connecting those dots between the overlay and underlay. Without VPN 0, there is no possibility of overlay to understand the underlay. It's the location of various destinations. See, the transport network is the underlay between the sites. The underlay link provides the framework for what? For the T-logs. And the overlay network to route between the sites using OMP. You understand the statement? Let me repeat. The underlay links in what they are public network, service provider, that provides the framework for T-log, that provides the necessary information for the T-log so that this T-log can be used by V routes, overlay routes, to reach various branch office. And the overlay network provides the route between the sites using which protocol? OMP. T-log cannot be distributed just like that without any protocol. Who has to distribute this? OMP. So T-log is just a framework built based on the underlay network. Now this T-log information, the location of various LAN networks in various branch office, need to be advertised by a protocol. That protocol is what? OMP. Now you also understood a little bit about T-log, and you also understood what OMP is. Now that's about the underlay connection with the overlay T-log. So what I was saying is T-log informations are nothing but the information about the underlay that is provided to the overlay to use. Now this information is advertised between the branch offices of SDWAN using a protocol called OMP. Now coming to the service network. What is service network? The SDWAN tunnels that are going to provide you various services. If I want MPLS service, there is one specific tunnel. If I want IPsec, I have another tunnel. Yeah, we have different service networks. They are called as service networks. Yeah. So overlay is what provides you the service network. Right. Okay. So service networks are used to use. Or the user route that will be advertised to, as I said earlier, advertised into OMP, and the OMP routers themselves, so that one side can ping the other side. I think I have to put it in a simple way. We have site A, or as I said earlier, Mumbai, Bangalore, Pune, Delhi. So how the service network is built? The user routes, they are exported into OMP. So from Mumbai, the LAN networks are exported into OMP, like West Delhi, West Pune, West Bengal. They all export the routes into OMP. And now they don't have direct communication. They communicate through vSmart. vSmart listens to all this, and vSmart provides the cheapest route depending on the traffic type, the cheapest route or more reliable route, the faster route, whichever you ask for, depending on the policy that you specify in the vManage. If you have a policy from Mumbai to Bangalore to use the cheapest path, yes, please. Yeah, yes. Yeah. But no idea about underlay. You will not be knowing anything about underlay networks. Underlay networks are going to be only encapsulated on the top, upper layer. We provide colors. We provide the color. We provide the link information. That's what we are going to get into in some time. We will provide that coloring. Yes. So now the service networks or user routes, OMP advertises that, and vSmart learns it and it knows the entire topology. Now, depending on the configuration that we have put on vManage, like I want a reliable route, or I want fast route, I want cheap route. Depending on the traffic type, a service network will be provided for the traffic to use. So in WebTel, it is simple, WAN interfaces are transport networks. LAN interface on the inside of the router or the user networks. Right. And also, we spoke about VPNs, right? VPN 0 is a transport network. The VPN 0 network provides the underlay capability for the overlay to run on top. This answers your part of your question that you asked a few seconds before. So VPN 0 is a transport network, means T-log information. It's nothing but the information about the transport network. That is why it is called as what? Transport locator, T-log. So VPN 0 is a transport network that provides the underlay capabilities, underlay capabilities, MPLS, IPsec, GRE, simple IP internet, fast route, cheap route, reliable route. Underlay capability. So underlay capabilities, all it includes, all. It is advertised through VPN 0 for the overlay to run on top of it. Next is VPN 512. You remember I was also talking about VPN 512. VPN 0 is for the transport network information to be known to overlay. Now VPN 512 is the management network, not the transport network. This is the management network between sites. VPN 512 is the management network for what? For updating the vSmarts, the vManagers, to make changes to the configuration. So whenever I do some changes on vManage, the path change, immediately 512 will go and inform vSmart. And vSmart will decide what path to give for the end user according to the new changes that has been done by us in vManage. You understand? Let me repeat. Traffic is going via MPLS. All of a sudden, you decided not to use MPLS. So you go and configure that new policy using vManage, and you can see the configuration. After verifying it, you say, boom, deploy. As soon as you press the button deploy, the configurations that you made, the new policy that you made, goes to vSmart. vSmart has got a complete picture of the topology learned through VPN 0, the transport network VPN 0. So now it picks one path that matches your policy which you recently corrected. For that, it advertises the TLOC information to the edge device, using which now traffic is going to be delivered. Does that make sense? Is it connecting the dots? Yep. No. vSmart will now decide the route on behalf of edge device. vSmart knows the complete information. vSmart will decide what should be the next stop on the edge device to meet this new policy requirement and push those vRoute information to the edge device. Edge device is only a data plane. They don't do any calculation like control plane. No policies are sent to edges. The determination is done by vSmart. For all this, VLAN as a VPN 512 is needed. Yeah, these two VPNs. VPN 0 and VPN 512. No user traffic will pass through this VPN. These are messaging channels. Correct, no? VPN 512 is messaging about the changes to the policy, changes to the configuration. VPN 0, it provides the underlay capability for the overlay to run on top of it. So these are all messaging channels reserved to provide a SD-WAN overlay network. Finally, we have VPN 1 to VPN 511, and then from VPN 512 onwards, sorry, not 12, 13 onwards, 12 is management. What for this one? For the customer traffic. To route the traffic between branch offices, between the sites, you need multiple VPNs. I have for some destination I want IP. For some destination I want MPLS. And I got 2 data center. So how many VPNs you will have? 4 VPNs now. 2 data center, 1 each VPN, and 1 for MPLS, 1 for internet IP. So beyond 513 and between 1 to 511 is customer traffic. It's going to be routed. These are the user routes or the service routes. You can call it as user routes or service routes that uses this VPN. Or you can also call it LAN network or policy-based service like security, IDS services, and so on. Service routes, user routes, service routes. So our focus is not on the underlay. Our focus is to provide firewall security service or IDS service or IPS service, some special services. So SD-WAN focuses only on the services that we want, not the underlay. Yeah. But for this to happen, the underlay information needs to be advertised worldwide. Right. So overlay management protocol, yes, means TLOGs need to be advertised. No, who distributes it? OMP advertises it. Correct. See, what did I say? Worldwide. If you have SD-WAN between multiple sites which are in different countries, that's what I say worldwide. In our example, it is not worldwide. No, it is within India, Mumbai, Bangalore. So it depends. Throughout the SD-WAN fabric. That's what the word I should use. Throughout the SD-WAN fabric. Now, who does this? OMP does this distribution. Correct. So let's learn more about OMP now. Overlay management protocol is the magic that makes all this happens. And this is configured by default. So when you connect the edge device, OMP will be up. You don't need to enable it. All right? It is configured by default to come up whenever the edge device is connected to a vSmart device. That is the condition. The edge device need to be connected to vSmart. As soon as you connect to vSmart, OMP will come up. As I already said, OMP is not going to run in between. Complete. OMP does not run between VH devices. VH devices. VH devices. They don't run between edge devices. They are only between VH to the vSmart. These are all the things that you can expect from a quality interview. Quality interview. Now, the OMP routes are also called as V routes. Means OMP provided routes are also called as V routes. I think by this time you should know why it is called as V route. Because it is not related to any physical underlay topology. It is purely based on the policy that you wrote in vManage. The vSmart provides you one route. So OMPs or OMP routes are also called as V routes. What do these routes carry? They carry the prefixes of the network and the interface information of the edge router. Usually they are advertised using the command called advertise, or you can also use a static or connected or redistributed from OSPF and BGP protocol. So simply the OMP carries whatever you advertise from edge device. From the inside network of the edge device, you are advertising, you are injecting into OMP by using an advertise command, either by static or connected or redistribute from OSPF or BGP protocol. So one thing what we have learned now is how the V routes are injected into OMP. It is through advertise command. Using advertise command on the VH, we provide prefix information to OMP. Every edge device will do that. You can also, they're either static, connected, or redistributed from OSPF or BGP protocol. Now, they need TLOC address for the forwarding of packet. For actual forwarding, they need TLOC information. So OMP uses the TLOCs. What is TLOC? They help to identify the transport VPN link. They are the one, which provides the information of which VPN to use, what system IP, what color, what link, what type of WAN interface, what type of encapsulation like IPsec or GRE. So all these informations are provided by TLOC. So OMP uses TLOCs. They identify what does TLOC provide. They identify the transport VPN links transport VPN links that are defined by system IP, color of the link, type of the WAN interface, encapsulation type. A few more is coming later. No, I do not want to get into TLOG. We are still in OMP topic. So OMP carries this TLOG information. TLOG is just only one part of SD-WAN solution that is related to the underlying network. The service route is a route that binds the OMP routes to a specific service in the network. Do you understand the statement? OMP route. See, OMP means it may be fast route, normal route, secure route, reliable route. It can be any. There are various VPNs, no, various routes. OMP knows various routes depending on the service that you need. Which TLOG or which VPN to use is what called a service route. You understand what is service route? For the service that I need, what is the TLOG? What is the next hop? You understand? What link I should use? What transport I should use? Right. So, yes. So V routes, they need TLOG. You understood that? Virtual routes needs TLOG. TLOGs are like tunnel endpoints. First is to have this TLOG, what is needed? A local user route. Correct, no? Locally, users are advertising from their LAN network. They're advertised to whom? Wow, you got the point. Advertised to vSmart. Now vSmart knows about all the local users, not only from one side, from all sides it knows. Completely. Now, according to the service that we need, based on the configuration that you provide and that we manage, a service route will be provided. And the service route TLOG information will be pushed to the edge device, and edge device will use that TLOG information to reach the destination using the service. So these three types of routes OMP propagates. OMP propagates local user routes, advertised. The OMP takes those local user routes and advertise to vSmart, and vSmart provides the service route to the edges. OMP routes are also called as P routes, or the routes that forwards the user traffic. User traffics are forwarded using OMP provided routes, not any random routes. You know, we used to say in the routing table, the best route. You will have 10 routes, but only best route will be in the routing table, right? That is what here we call as OMP routes. OMP route is the route that satisfies the service policy. So the user traffics exist in the VPN between 1 to 511 and 539 above. Right, they are the user routes. So to have a recap in this particular topic, the user routes are advertised into OMP from the local router to the vSmart to say that I have these networks so that they can reach through me. They may be connected to an interface, or they may be deep inside the LAN network where we have a static route to reach that network, or maybe I have a redistribution from LAN protocol like OSPF, or I may be redistributing from another WAN using BGP. So this is somehow from the customer's internal network we learn. Now these routes, they have many attributes. This is very, very important part we are getting into now. It's not BGP attribute. It's virtual route OMP route attributes. The route attributes for OMP routes or V routes. Number one, the T-log. OMP routes will have a lot of attributes. Number one is T-log. T-log is what advertised as the next hop for the router. Next is the T-log contains also system IP. What does T-log contain? System IP. T-log is nothing but what? Transport locator. It is directly related to the WAN link in the transport. You saw that, right? Underlay network. It's a WAN link. I was giving you an example. No? If I want to go to the 10 network from Bangalore, what public IP address I should go? The early class I gave you another example, DMVPN scenario. In order to reach that tunnel, GRE tunnel IP address, what is the public IP address I should go? Using NHRP we resolve. Here OMP is what we use to resolve. So the transport locators are directly related to the WAN link in the transport. So if your edge router has two links, one to the public internet, another one through the private MPLS cloud, then we will have how many T-logs? Two T-logs, exactly. So there may be also color, labeled with color, public network, private network, MPLS. So these are all colors. Public network is one color given. MPLS is another color given for private. Right. For example, these T-logs are are used by OMP to find the next hop for the V routers, mid-service routers. So only with the T-log we can identify the endpoint for OMP tunnel between the router and the vSmart. Okay, so the T-logs will have system IP, they will have color. There may be multiple variations in MPLS like high priority MPLS, low priority like gold, silver. That is what QoS. MPLS with QoS, or GRE tunnel, or a tunnel with IPsec, a tunnel with specific site ID. Is there any NAT involved in reaching the network? All these informations will be inside T-log. All right, T-log. So OMP route has got many attributes. One is T-log. Secondly, see, I've told many. I've just written only one. Color. System IP is the kind of public IP address from where the network is advertised. See, if I'm advertising from Bangalore, I'll have one WAN IP address, not to give you. That you will use as the next stop to reach me, right? So if I'm advertising through MPLS, there will be one address. If I'm advertising through internet, so this TLAG has got a lot of attributes. OMP has got a lot of attributes. Number one is TLAG. Secondly, origin. Origin is to say from which protocol this is originated. Whether it is from the customer side, whether it is originated through static route or OSPF, redistributed through from some other protocol, OSPF, connected, BGP, etc. with the metric. Right, so origin is the attribute that carries the protocol information. The protocol information is nothing but how the route is originated, static or connected with the metric. Yes. Third attribute is the originator. Originator is the IP address from where the route has been propagated. That's originator. Originator is the IP address from where the route has been propagated. The next attribute is the preference. It is same like local preference in BGP. Preference is a value for which the routes are preferred if there are more than one. Higher value is preferred. Come again. This preference value we will set in the vSmart. We'll set the preference value. We will be learning route from multiple WAN connections. We set preference. I prefer MPLS for this destination. So we set higher preference value. So vSmart will use that link's WAN address as a TLOG address. Okay. So preference is to prefer route if you have more than one option. Or I said in MPLS itself you have gold MPLS, silver MPLS. Which one you want? If gold is preferred, then high weightage is given to that, so that for those destinations only gold MPLS. Gold is the color given to the MPLS path. All right, so that is preference. This is another attribute which is carried by OMP. And then fifthly, service. So, service value means, uh, depending on what service you need, different tunnel is going to be taken. So to mark that service, you have a value. This is again, not every time. Only when we have some specific service, the service value will be used for special services. I want a path with, let's say, bandwidth not less than 512 MB, right? Something like that. So depending on these things, you see, mostly you will have this preference itself to, but on top of that, if you want more, you can go more granular. So this is only if you have some special services, you will have the service thing. So service value is only for when you have service routes, when special service route to be used. And then site ID. Site ID is like a router identification of the advertiser. So if your edge router is advertising, you will have a identifier. So it's not a WAN IP address. It is not a system IP address also. It is a kind of identification to the edge device given. You can compare this to a router ID in OSPF. Have you seen router ID? Sometime you will not. No. I know you have seen router ID. Have you seen router ID where we don't have that IP address on any of the interface? It is just an ID. You can manually configure, no? So that is what site ID. Site ID, you can compare this to. Yeah, correct. Correct. Next is there is another attribute which OMP carries called tag. Tag is again optional attribute in OMP. If you want some more special attribute, then you may use some special tags to, like you used to have community. We have a lot of attributes in BGP. Why we have another attribute called community? That's kind of tagging mechanism. It's not needed unless it is really needed. So always community is not used in BGP. Yeah. So we have seen up to tag, right? It's a tag is an optional for mapping. Next is the final one is VPN ID. We already spoke about the VPN ID. VPN ID, which is matching the network segment that the OMP route will be attached to. VPN ID, see, VRF, right? From the MP-BGP tunnel, there are many routes coming. The routes are taken from the tunnel and given to a specific customer. through VRF. That mapping happens, right? Exactly the same work is what the VPN ID also does here. Right? So VPN ID is which the network segment YMP routes is attached to. It's very much like VRF. Fine. So these are all the attributes of YMP. 3, 6, and 8 attributes. T-log, system IP. Origin, which protocol. Originator, the IP address of the router from where it's coming. Preference, if you have multiple routes, you can prefer one. Services, if you have special services, special path, you need. Site ID is like a router ID. Tag is an optional one, again for some special marking. VPN ID is like a VRF, so that from the SDWAN tunnels, the routes will be given only to the correct router, correct receiver, not to everyone. We'll be able to differentiate, right? So this is the routing side of SD-WAN. We have seen the routing side of SD-WAN. So we got two more, at least three more theory class in SD-WAN to finish the complete knowledge on it.